Okay, let's divide some polynomials. First, we're going to divide, just do some old-fashioned long division because we're going to use the same process with polynomials. I know it's probably been a long time since you've done this. So, this is 3,480 divided by 7. So first thing I'm thinking, does 7 go into 3? Well, it doesn't. 3 is too small, right? So then I think, does 7 go into 34? And it does. 7 times 5 is 35, so that's too much. So I can put it in 4 times at most, okay? And then I do 4 times 7, and that comes out to 28, okay? I put that right there. And next, I'm going to subtract, okay? So this is going to come out to 6, right? 34 minus 8 is 6, okay? So I put that there. Then I'm going to take the 8 and pull it down like so, all right? And now I'm thinking, how many times does 7 go into 68? Well, 7 times 10 is 70. That's too much, but it will go in 9 times, right? So I'll put a 9 up here in the answer bar up there. And then I'm taking 9 times 7, not 49 times 7, just 9 times 7. 9 times 7 is 63. Okay, I subtract again, and I get 5. I'm going to pull down the 0. And then 7 goes into 57 times. And 7 times 7 is 49. Okay? And then I subtract one more time, and I get a 1 down there. So my remainder is 1. And a lot of times people write 497 remainder 1. And that's fine, but I want to do this a different way. So what I'm going to do is the remainder is going to become the numerator. And whatever you're dividing by is the denominator. Okay, and we're going to add in a fraction. And this will be the top of the fraction, that'll be the bottom. So this is going to be plus 1/7. Okay, and I know you probably wouldn't do this division like this by hand, but you could if you did this with a calculator. We're going to get that. And so it's 3,000, it's 497, just like we got. And the decimal part is 1/7. So if you do 1 divided by 7, you can see, oh, that's the same as that decimal part, right? Okay. All right, so let's try this with long division. So what you want to do with long division with polynomials is just concentrate on the first terms of both parts here, okay? So I'm thinking x times what equals x squared? Well, it would be x, right? X times x is x squared. So I want to put an x up somewhere here, and you would think it would go right there, but what you want to do is put it above the like term. So x, if I want to put an x up here, I want to put that above the 6x because that's the like term, okay? Then I'm going to take x and multiply it by the whole binomial, not just by x. So x times x is x squared, that's true. But then I also want to do x times 4, which is 4x, and I'll put the 4x here, okay? And I'll put a plus. So x times the quantity x plus 4 would be x squared plus 4x, okay? Now, here's the part that people forget. People often will add these together. They'll see 6x and 4x and say 10x. And I understand that, but remember what we were doing here when we put that 28 down there. Then we subtracted it from what was above, okay? So I actually want to subtract this whole quantity, okay? So you want to think, okay, x squared minus x squared is 0. And that should always work out like that, right? But then 6x minus 4x is 2x. Okay, so I was taking these two terms and subtracting x squared plus 4x from them. And that gives me 2x, okay? So those cancel out. And I got 2x there. That's the most common mistake is people will just write a 10x there, okay? And I'm going to pull down this 8, all right? And then I'm looking at just the x and the 2x. I'm thinking x times what equals 2x? Well, that would be 2. So I'm going to put a 2 up here in the answer bar. I'm going to put it above its like term. And then I'm thinking 2 times the quantity x plus 4. To distribute the 2 in, right? And up there on the answer bar, I want to separate those two terms. So there we go, okay? And then this one, when I subtract, well, 0, and 0. So I got no remainder. So x plus 2 goes in evenly. Okay, and you could try it out. X plus 4 times x plus 2 does equal this trinomial. Or you could just factor that trinomial, and it'd be x plus 4 times x plus 2. So there's our solution. Okay, that was our solution on the last one. All right. Okay, so let's try another here. So I want to rewrite this in long division format. I'm dividing by x plus 4, so I set it up like so. Now, let's say that this didn't have an x squared term. It just looked like this, x to the third minus 6x minus 7. You'd want to put in a 0x squared as a placeholder if that were the case, to have everything line up nicely with long division. This isn't missing any of the terms, so I just write it as it is. Okay, and you'd also want it in descending, in standard form with descending powers. Okay, and that one already is. Okay, all right. So starting with those two, so I'm thinking x times what equals x to the third. That would be x squared. And I'm going to put the x squared above the like term. Okay, then I multiply back. Okay, and then really tempting to add these, but we're subtracting, right? So those cancel like they should. 3x squared minus 4x squared is negative x squared. So this is not 7x squared. Okay, pull down the negative 6x. And then I'm thinking x times what would be negative x squared? Well, that would be x times negative x. Okay, and then negative x times the binomial. So I'm taking this piece and multiplying it back by x plus 4. That gives me negative x squared minus 4x. Okay, and here especially I get people write negative 10x down there, but nope, we're subtracting. So think of this, if you won't need to do a little side problem, go ahead and do that. Negative 6x minus negative 4x. So that would be negative 6x plus 4x, which would be negative 2x. Okay, I'm subtracting, so you're subtracting a negative, right? So it's like adding 4x because we're subtracting a negative. Okay, pull down the negative 7, and then x times something equals negative 2x, that would be negative 2. Okay, and multiply back, negative 2 times the binomial gives me negative 2x minus 8. Subtract once more, and again, not negative 15, it's negative 7 minus negative 8. Negative 7 minus negative 8, well, that would be negative 7 plus 8, which is 1. Okay, so don't say just remainder 1. Now we want to build a fraction. Okay, so I'm going to say plus, the 1 goes on top, and whatever you're dividing by, in this case x plus 4, goes on bottom, and this is my solution. Okay, so even when it doesn't go in evenly, we can still do the division. Okay, here's another one to try. So x goes into x to the third, x squared times, it'd be x times x squared to get x to the third. Put that there. Multiply back by the binomial. Okay, subtract, so those cancel. Negative 4 minus 2 would be negative 6x squared. Okay, and then I'm thinking x times what is negative 6x squared? That would be negative 6. Negative 6x, sorry. And negative 6x times the binomial. Oh, not yet. Let me pull down to 3x. And now negative 6x times the binomial. Negative 6x squared minus 12x. Okay, and again, I've got a double negative here, 3x minus negative 12x. That's going to be 15x. Okay. Pull down the 2, the plus 2, and x times 15 would give me 15x. Got a 15 up there, multiply back. One more round of subtraction. And there's the numerator. So you could say minus and then the fraction, but I always just add in the fraction and then, my numerator is negative, but it doesn't really matter. So I always get people ask me, is that the same as saying minus 28 over x plus 2? Yep, it is. Subtracting 1/2 and adding negative 1 over 2 is the same thing, right? Okay. All right, let's move on to the next page. So there is a shortcut that you can use called synthetic division. You can only use this in certain circumstances. You can only use this when you're dividing by a binomial in this format. It's got to be x plus or minus something, okay? So if I look at these examples, I was dividing by x plus 2. I could use synthetic division here or here. But if I was dividing by 2x plus 2 or 3x plus 2 or something like that, I could not use synthetic division, okay? All right, so let's try this one out. So here's how synthetic division works. What you want to do is take whatever you're dividing by. Okay, and I'll write it up here just in the interest of space. And set it equal to 0, and then solve for x. So x would equal negative 5, okay? Now you wouldn't normally need to write that out, but you need to think what the x would equal if this were set equal to 0, okay? So in this case, negative 5. So I'm going to write negative 5, and I'm going to put it in a little box like that. Okay? Now you got to bear with me for a second. It's going to seem a little weird, but it's actually really easy and really quick once you get used to it. Okay? Then what I'm going to do to the right of this, I'm going to take the coefficients. So I've got 1x squared, then negative 2x, negative 48. So my coefficients there are going to look like this, and I'm spacing them out a little bit. Okay? If this had any missing terms, like if it went x to the third minus 2x squared minus 48, well then I have to put a 0 in as a placeholder if it's missing any of the terms. This isn't, okay? Then I leave a little space, and I'm going to put a bar, but leave some space in there because we're going to write some numbers underneath the 1, the negative 2, and the negative 48, okay? And then under the last term here, which is negative 48, I'm going to put another little box like that, okay? All right, so here's how this works. The first number, you're just going to pull it down to the bottom. So I got a 1 there, and then so I just put a 1 down there. Whenever you put a number below this bar, you're going to multiply it by this number. So I'm going to do negative 5 times 1. Negative 5 times 1 is negative 5. Okay? And then I'm going to add these two numbers together. I was really adding 1 and nothing here, so that's why I got 1. If I add negative 2 and negative 5, I get negative 7. Okay, now I've got a number down here, and I'm going to multiply that by negative 5. That gives me 35. Okay? And then I'm going to add these together. So negative 48 plus 35 is going to give me negative 13. Okay? And this number down here, I call this box the remainder box. And that number isn't the remainder, but it's the numerator of the remainder. Okay? So I know my remainder is going to be negative 13 over something. Now what is the something? Well, it's whatever you're dividing by. In this case, you're dividing by x plus 5. So there's my remainder, okay? And then the negative 7 is going to represent the next term over, which in this case is just going to be negative 7, okay? And then as I go to the left, this is going to be 1x. If there was another number, it'd be something x squared, then something x to the third, and so forth. But this is just x. And I make sure my here, since that's negative, those are already all my terms are separated there, but there's the terms. Okay, and you could try this out with long division, you would get the exact same result. It's not really much quicker when it's a pretty small problem like this, but when it gets to be a longer problem, this would take me a while to do this next one with long division, but I can do it really quickly with synthetic division. Okay, so let's set this up. So, I'm thinking to myself, oh, if x minus 3 equals 0, then x equals 3. So that's what I'm going to put in that top left box. Okay? And then I'm going to use these coefficients, and I can see there's no missing terms there. So that's just the numbers, right? Okay, leave a little space, another bar, and put that little thing, okay? So I'll pull down the 2, then I'm going to multiply. 3 times 2 is 6, then add, multiply, so it's like multiply, add, multiply, add, multiply, add. 3 times -5 is -15. And then I added those to get -10. 3 times -10 is -30. And then add these to get -24. Okay. And then 3 times -24 is going to be -72. When I add these, I get -90. Okay. And now what I have to do, all I have to do is build this back into a polynomial. I can't just leave it like that. That's not really telling me what the result is when I do that division. I mean, it's telling me what the polynomial is, but I still have to build the polynomial. So I like to start from the remainder. Okay, so I'll do this out here. So I've got -90 as the numerator, and then x minus 3 is my denominator. Okay, and as I work my way left, this is just going to be a constant, so just a number. And then I'll add 1 degree of x every time I go to the left. So this is -10x. This is -5x squared. And this would be 2x to the third. Okay, and there is my result. Another way, if you want to build your answer from front to back, you can just think, well, 2x to the fourth divided by x would give me 2x to the third, right? So I know my first term is going to be 2x to the third, and then you can kind of just use, as you go right, you use 1 less degree of x every time until you get to the remainder. Okay. All right. Beware on this next one. There's no x term in there. Okay. So when you set this up, I've got the 3, then I've got 8, then I've got 5, but I need a 0 as a placeholder. Otherwise, it's not going to work out. There's no x to the first term in there, but I could write it as 0x. And that will change your answer, okay? So always be scanning for missing terms. So I pull down the 8, then I multiply, add, multiply. Let's see, 3 times 29. I've got 87. Add, multiply again. 3 times 87 is 261. And yeah, you know, you've got some addition and multiplication to do, but you don't have to juggle all of this stuff that you would with long division. And then you just have to know how to build this back, okay? So let's build it from front to back just to show you. I know 8x to the third divided by x would be 8x squared. So this should start with 8x squared. And then I'm just going to go down a degree, so 29x. This would be 87. And then I'll build my remainder. Okay. Okay. Next up, and again, if I was dividing by 2x minus 3, I couldn't use synthetic division. So just a heads up there. But all of these did qualify. Okay. One other thing I can do with synthetic division is evaluate functions. And it's called synthetic substitution. It's pretty much the same process. The only difference is instead of putting, I'm finding f of 4, which, yeah, I could just plug 4 in for x and do it the old-fashioned way. But I can also do this. I'm going to put a 4 in, not a -4. I often see people put a -4 because they're thinking of synthetic division. But with synthetic substitution, just put in your x value in that little box. Then I pull out these. I'm not missing any terms here. Okay. I'm going to do this just like I would with synthetic division. So pull down the 3, multiply, add, multiply. Let's see, 40 and 16, that's 56. And then got 55. And 4 times 55 is 220. Okay? And whatever you wind up with in the remainder box is actually your solution. So f of 4 should come out to 225. And that's the same result that you should get if you actually plug 4 in for x in all the places and simplify. Okay. So, it's more useful when you have a really long polynomial because it wouldn't take me that long to plug in a 4 and simplify. Let's try it again here. So I'm going to put a 3 in the box. Let's see, do I have any missing terms? I don't. Okay, pull down the 2. 3 times 2 is 6. 3 plus 6 is 9. 3 times 9 is 27. Negative 4 plus 27 is 23. And 3 times 23, that's going to be 69. 1 plus 69 is 70. So boom, f of 3 should be 70. Okay, and that's it. See you next time.